So I'm actually happy today that we're going to host another seminar series, actually, which is a session 47. Today we're actually going to be very honored to have Aaron here from University of Florida to join us to share with us about his recent research. So Aaron is actually associate professor in the management department at the University of Florida. So his research is pretty much focused on strategic leadership and corporate governance. And then he mainly does publishes a lot of articles related to the strategic leadership and how they make the decisions, as well as what the outcomes of those decisions on the firms as well as individuals. So Aaron, has been publishing, as I mentioned, in AMJ, Journal Management, Strategic Management Journal, as well as Org Science, etc. Okay, so we are really happy to have Aaron here today to share with us about the multiverse analysis to test and build a theory of like using the CEO gender pay equality to illustrate this multiverse analysis. I'm actually very interested in learning how this is, what is this is about. Aaron, thank you for joining us, and then the floor is yours. Now I'm actually going to stop sharing, and then you can share your slides.
Okay, well, thank you for the very kind introduction. I appreciate it. So let's see, I will share my screen. So you should see my slides.
We see your screen.
There we go. Is this good?
We
don't see a slide.
You don't see my slides.
No.
Okay, let me try again. Okay, stop screen share. So share screen. Screen one. Okay, so you see my slides now?
Yeah.
Yeah.
Good.
And I should do. Good?
Yeah.
Good.
Okay, fantastic. Well, thank you again for the kind introduction and for having me present tonight. I liked your little globe logo. It reminds me of one of the prominent features on our campus here at the University of Florida, which is our mascot, Albert the alligator, standing on top of a globe. So you can see here. So yeah, nice fitting tie-in together. So tonight I will be presenting multiverse analysis, which is a relatively new tool, and it's a way to help us better test and build theory. And I'll talk a little bit about the tool itself, and then I will try and illustrate with the example of gender pay inequality. I will try and manage the chat feature. So if you have questions, please go ahead and jump in, or you can save them till the end. And if I happen to miss someone raising their hand, Wei or Wally, feel free to jump in and let me know. So yeah, thank you again. And good morning to those of you who are in China, and good evening to those of you in the US. So thank you for spending your time with me. So I'll give you a quick overview of where we're headed in the presentation. I'll do a very short autobiography, building a little bit on the introduction, just to try and contextualize why I'm studying what I'm studying. I'll give a general overview of multiverse analysis, so there's some familiarity of the tool itself and what it is trying to accomplish. Then I'll do the illustration with CEO gender pay inequality research. And finally, a short discussion, and then open up for Q&A. So that's broadly where we're headed. Before I start, I want to first acknowledge my co-authors. This research was conducted with Christina Carnes at Indiana University, Martin Getz, who's at University of Zurich, and he's really the one who initially introduced me to multiverse through Ernest O'Boyle, who is a longtime friend in the field and co-author at Indiana University. And any errors in the presentation are mine alone, although I very much appreciate their help and insight in putting this presentation together. So acknowledgements to my co-authors there. So for short autobiography, as she said in the introduction, I study strategic leadership and governance, and I'm primarily focused on what drives strategic leaders, mostly executives, but also politicians, to act in the way they do, and then what are the ensuing implications. As I focus in that area, I'm often interested in the context of the executive labor market. So this would be things like where people move, drivers of CEO selection, top management team selection, but then that's also where an interest in pay came into play. So we'll talk a little bit about CEO pay tonight. Over time, I've developed an interest in research methods, and this initially truly started out of necessity, kind of at the interaction of these areas and trying to become a better researcher. I needed to learn more in the research methods space. And so over time, I've developed an interest in research methods. And tonight's talk will intersect all three of these areas: strategic leadership and governance, talking about pay in the executive labor market, and then introducing a relatively new research method, which is multiverse analysis. So as we delve into multiverse analysis, just for short, I'll just refer to it as multiverse going forward. I'll give you a brief overview of what multiverse is by way of background. So the introduction to multiverse really is 2011, and this is Simmons et al.'s work, and they refer to the garden of forking paths. And what their primary idea is that there's researcher degrees of freedom, and these degrees of freedom that we have as researchers will affect our results. So these are things like choices in constructing our sample, how we might measure a particular variable, how we might specify a model, whether that's with certain control variables or not. So for those strategy scholars on the talk, very familiar with a litany of control variables. For more of our micro scholars, we often don't use control variables, so that decision alone can affect our results. And then often we see different analytical approaches. And so this is not by any means a new insight, but they put this together and kind of said, we should really be looking at all of these forking path decisions and how the choices affect the results to get a little bit more robust understanding of the relationship. So in the context of our research projects that we're working on, the sheer number of choices that we have create a number of issues. As soon as we move out of maybe the gold standard of an experimental setting where we can control for a lot of factors through random assignment and really isolate our manipulation, the sheer number of choices that we have is going to create issues. And as we begin to try and parse those down, we're going to have time limits just as humans. We're going to have cognitive limits in terms of what we're familiar with, what we may be able to tackle in a series of robustness tests. And then as we try and present that in a journal, certainly we're going to run into page limits. Now we're getting better as a field with respect to having online repositories where we could put numerous pages. But even then, if we had 10 or 12 pages of tables or 20 pages of tables, that can be a lot. And that may just be a small fraction of the total number of possible analyses that we could run. In many of these situations, there's a trade-off where there's not necessarily a clear right or wrong. And so something as simple as how we would control for firm size. Do we use something like assets? Do we use employees? Do we log that? There's many alternative choices, and there's not always a clear right or wrong. In some instances, there's a clear right or wrong, but in others, it's many shades of right or wrong or different, equally justifiable alternatives. So even given all that, even with a really detailed or well-crafted explanation, Gupta et al. Point out that there's almost always key pieces of information missing that make it hard to know exactly what the researcher did in terms of how they measured something exactly, how their sample was derived with respect to missing data, et cetera. So it can be very difficult to parse through this. And some of that vagary has led to a number of questions in our field, which I don't necessarily want to go into some of the potentially questionable research practices, but this can occur. And so multiverse is a step to address some of these issues. So this, out of all of these issues, which is the kind of vagaries in terms of what we can accomplish as scholars, our time limits, our cognitive limits, the sheer number of reasonable alternatives, is trying to get robustness and reliability of theory given these issues. So Sarma et al. Is a recent tutorial building off Stegan et al.'s work, who really coined the term multiverse. If you're looking to, and I'll have these sites and some other examples later, if you're really looking to dive into this, Stegan et al. Basically said, hey, we can systematically run all of these tests, and developed what they called the multiverse analysis. And Sarma et al. Pushed that forward by sharing code that can accomplish the multiverse to help us, because it can be computationally complex, but with their code, which also let you know, we'll share our code here. This can help make it much smoother. So the metaphors that are often used in a multiverse is to use a term like a path, so the garden of forking paths, or a decision tree, or so this path or tree of analysis where each fork in the path or each branch in the tree depicts a choice between options. So in our traditional analysis, maybe we'll run some robustness tests, but at least traditionally, going back many years, we would only report the very most robust, best alternative analysis, even though potentially we conducted others. Now, this could be a departure where people could use this for questionable research practices. Again, I don't really want to go in that direction, but this is kind of the traditional way we would do research, is we would build out our best argument and we would present our most robust finding. So we'll call that the traditional analysis, or this is what Sarma calls the traditional analysis. In a planned analysis, which is growing in popularity in a number of fields, we would a priori establish what our best analysis would be, and then we would go and conduct that analysis. So very transparent, but again, in some cases, we may have multiple paths or multiple branches that are equally justified. So while the planned analysis gives us insight, we may be missing something with respect to what about an alternative decision that's equally justified. And this is where multiverse comes in that it helps us report the totality of all potential paths or all potential trees in this fork or branch metaphor, all the potential justified analysis in aggregate, so we can get a real clear depiction about how robust the relationship is. So this is intuitively what multiverse is trying to accomplish, is to give us a broader picture of the relationship by analyzing the multiverse rather than single universes of analysis. So if we use this tool, this can help identify if we have consistency or variability in our results across these alternative justified choices in a systematic way. So if we look at Sarma's model here on the far left, and we think of this traditional analysis, it may be here that of the 9 analyses depicted, all inform the same conclusion. And then we have a nice robust set of findings where 9 reasonable alternatives all land at the same place. It may be in the right analysis, the multiverse analysis, that some of the alternatives therein, so out of the 16 total analysis, that some of them reach a different conclusion. And if that's true, then we want to know why, or we want to delve into why and see if there's different explanations, if we have sound theory for that, or if we really have a multiverse where 9 of the relationships point one direction and the 7 that aren't reported point a different direction, to where we have confounding knowledge on a broader scale. So this will give us a little bit better insight into the true robustness of the relationship. So in aggregate, this should provide us evidence that offers not only better testing of and confidence in our theory and results, but to the extent that they don't agree, it'll offer insights to help us build theory, such as where is the variability, and then digging into theory, do we have an explanation for that variability? And if we don't, that's a nice jumping off point for then building that theory going forward. So this is the background behind multiverse. Again, some of the terms, the path or the fork, we also then call a parameter, or our estimate of interest would be the end or the leaf in that path or tree with one or more fork or branch. So you get hopefully you get the analogy here. And there's various points along this path where an analysis must decide between reasonable alternatives. The end option is one of those forks or branches, and that end option creates what's known as a single universe. So this is the universe of all possible choices. of all of our, here, our sampling frame, our measure, our model specification, and our analysis. When we get to that end option in our analysis, that's what we would call a universe, or complete path from the start to the end, or root to leaf, etc. If we parallel that out, then many universes becomes a multiverse. And that's where the term originated. So why do we need multiverse? Or what does this add to us that we don't currently have just by conducting many robustness tests? First of all, is that the different universes may be beneficial and natural. Just as there's these many degrees of freedom that can enhance our robustness across universes, extending that further can give us more robust insights on the relationship. So it's, a 1-off or a 2-off or even a 10-off robustness tests, which are growing in popularity and is a good sign in our field that we're conducting more and more analysis and reporting them. But this will just extend that out. Second of all, in many multiverses, we'll have universes where there's mixed results that occur, such as the point of this paper tonight, CEO pay inequality. So we'll have different universes that potentially are even justified, so even removing unjustified universes where we have mixed results. And if that's the case, the multiverse can help us parse those universes down, identify the potential sources to then point to where we need to build theory. So hopefully it's a little bit more robust approach to trying to analyze this and pointing us in a direction that can help us build theory. Now, someone may be saying, hey, why do we need to do this? There are already solutions out there that can accomplish similar. And that is true for many research questions. We may not necessarily need a multiverse, but there are some studies that may be unable to resolve these mixed results, and that's where a multiverse can come in very handy. For example, as a strategy scholar, it's often difficult to move to a random assignment. We can't randomly assign conditions to firms, or we probably could, but firms are unwilling to let us just randomly assign different strategies. There'd be numerous implications of that. So we can't always do that, and it's not always possible to have an experiment that really produces the realism of the situation we're looking at. So it could be that, our gold standard of a random assignment just isn't possible in a given research area, or has too many limitations that raise red flags. So we could use multiverse in those cases to provide an alternative robustness assessment. You may be thinking, hey, what about meta-analysis? Meta-analysis are a very powerful tool, but inherently they start out as a bivariate approach. And these bivariate approaches may overlook vital factors. This is pointed out by Lambert et al. Also Chung. So we can point to those research and say, hey, there are some limitations here, not only in the bivariate approach, but then in the multivariate approach, we may have concerns about power because it's based on the number of studies that are the same and not necessarily the sample size in the bivariate relationship. So that's problem one. Problem two is these multivariate approaches have some assumptions that don't always hold. So meta-analysis, while powerful in many contexts, much like the random assigned experiment, they may not work for some studies. So again, there, multiverse gives us an alternative where we can get a little bit better estimate, or hopefully a truer estimate or some insight when an alternative technique that is available does not work. Finally, these robustness tests, again, we'll see papers with 10, 20 robustness tests. That's fantastic, but these usually are not exhaustive or entirely systematic. And so that opens up questions about, were they chosen in a certain way, or were they just the minimum of what reviewers asked for? And that's, while it's a positive step, we can still do more with a multiverse by being very systematic and ruling out the alternatives. So that helps hopefully give some background on multiverse. Of course, one tool cannot fully resolve all concerns, and situations change over time. So multiverse is not a panacea. It's not going to solve all problems. And because these situations change over time, we still need to return to theory. We still need theorizing, for example, about policy implementations that would affect change, norms in society that maybe would affect relationships over time, just time itself. Things change, the advance of a new technique, etc. So we definitely need theorizing. Multiverse is not intended to substitute for theory. But it can help us with strong inference testing because we can pit these theories head to head by being systematic in an aggregate analysis that pits all possible alternatives against each other, rather than showing a multiverse or a universe, rather than showing a universe or even a handful of universes where the data supports the theory. We test the entire multiverse of data, of options and analysis options and measurement options to see if there's true support for our theory. So it can give us a little bit better systematic test of the theories, which gives us better inference testing. Taken together, we should either have more confidence in our theory if the findings are robust and the multiverse points to very clear theory. Then we have very clear support for one theory, which chances are, if it's a head-to-head situation, then opposes another theory. Or the tool can help us identify the sources of the conflicting finding, which then can facilitate a more systematic theory building by helping us prune theories that weren't supported or where the data wasn't robust, sharpen our theory to where it was, and then extend into practice. So Multiverse is a very pragmatic tool that can help us in a number of ways. So I've tried to thus far sell you on, hey, Multiverse is a tool that we can use. It's not perfect, but it's something we could add to our arsenal, particularly in settings where we have mixed findings and we need to delve deeper. Multiverse is really well suited for that because it can help us with robustness tests and it can help us with building theory. So how? First of all, is extant theory should guide our multiverse construction, and thus we'll have that stronger inference testing. So we should, as we design our study, we should be having justifiable decisions or justifiable alternatives that go in, and that will help us inform a better research design. So in other words, we shouldn't have unjustifiable universes in our model. We shouldn't throw in analysis or measures that we know are bad, because that's just going to bias the results in the same way. So if we use extant theory, whether that's methodological theory or our theory of the phenomenon that we're studying or the mechanisms we're studying, we should be able to derive our justifiable decision points. At the same time, then, we can use that same theory to derive justifiable alternatives, perhaps even newly developed ones. If we go back, say, 30 years in the field, we'll see very simple regression models and even correlational studies that maybe wouldn't hold up by today's methodological rigor. So we could perhaps add newly developed methods into the multiverse and see if that changes results. So we can use this as a powerful tool to help identify that robustness or sensitivity. From there, the evidence that we generate can guide our theory building. If there's variability, this can identify the sources, which I'll talk about. And if we have sound theory there, then we just build or test that theory. If we don't, then that gives us an opportunity to say, hey, here's theory where we need to build about this particularly unexplained area. So it gives us a roadmap or a guide, which is something I particularly like, is that it really points us in the direction of where we need to go. So it's very helpful. And again, the results help prune or sharpen because they contextualize the extant theory, which then builds theoretical nuance. So we can find contexts where the relationship is one way, that it's not in another context, and that can help us build nuance around why in that context. So it offers a number of insights that can help us by following kind of this model. So from there, multiverse aside, I'm going to delve into the multiverse a little bit further in detail, but to give you a little bit of a glimpse about where we're headed is the area that I'm interested in, and this is why Ernest and Martin were particularly helpful for illuminating this to me, and Christina is also a strategic leadership and governance scholar. So when the four of us came together, this was like, multiverse is perfect for answering this question because we have gender inequality studies where we have contrasting theoretical logic. Some people that say, hey, women should earn a pay premium. Other people and other theories that say women should earn, they should have a pay deficit. And there's theory that actually says we should have neither. And the results are all over the place. So this is very well suited for a multiverse. It hits these three areas. And multiverse, at least I'll try and explain how it can help us reconcile the variability in those theories and the variability in these empirical results by systematically testing these competing theoretical rationales against each other and identifying the source of the variability, which then aids in our theory building. So it's a sound theory test, and the results, which I'll hopefully walk us through, will help us build theory, or that's the goal. That's where we're headed. So if we think about just a universe or an example of COP, this will hopefully walk you through the universe or the multiverse in a little more detail. We would have a sample. Let's say we draw the Fortune 500 over 10 years. We stop at 2019 because we're concerned about the pandemic. So at this point, people would say, yeah, this makes sense. It's 10 years, seems solid. We would use a measure of pay, which is TDC1 from ExecuComp, which is a very common measure of pay. We may specify our model with a number of predictors or control variables, things like size, things like price. So this would be a very typical study design. This would then create what we would consider as a universe, but there are several other alternatives. For example, we could add more years. What if we want to add 2020, et cetera? Or drop firms like banks because they have different compensation rules. So now we've increased our universes. If we had a different measure of TDC1, say we logged it or Windsorized it or scaled it by size, we'd have a handful of other universes, and we would times those together to now have 12 possible alternatives. If we added TDC2, we'd have a fifth one. And if we then took that by the same factor, we would now have 10 times this number. So it can grow rather quickly. Let's say we drop a control or add a new one. We're now up to 45 universes. If we try some alternative analysis, we have 180 universes that we've already derived. Very simply, we could probably derive many more. And so we can imagine digging into an AMJ or an SMJ or an org science or journal of management and seeing if this is the standard setup. This would be 180 pages just of our output, but also 180 pages of the descriptive statistics that would inform the measures for that sample, right? So we'd have a 360-page paper before we even explained anything about it. That's just the tables. So we can see how this is very untenuous, and we probably have many more universes that we could come up with. Again, we don't want to add unjustified universes, but we can also utilize the same process to compare those unjustified universes. So I'll take a step in that. If we think about unjustified alternatives, again, we don't want these in our universe. We don't want poor measures. We don't want unjustified samples. We don't want analytical approaches that are not justified. People misfit a model. They use an unbalanced regression for a balanced panel, or they use a balanced regression technique on an unbalanced panel. Those results are meaningless. They're incorrect. So we don't want to put them in our universe. But let's say we have them. Okay, this is not the main focus of Multiverse, but I have found that it's helpful to contextualize these unjustified alternatives by placing them in context. So this can be another tool that I think Multiverse can grow into. So I find it to be helpful to place these in context as a sound basis of comparison. For example, we may have a problem in an observation. Any of you who've worked with CompuStat data, you know that firms restate their financial statements, and it's roughly 20% of firms a year have a restatement. Now, some of them are material restatements where they restate something very major like their net earnings. Many of them are very minor restatements where, hey, they forgot to list someone with a fiduciary conflict, or they carried a zero wrong on R&D expense that maybe doesn't affect all of the studies, but maybe it catches your study. So we could identify problems and observations. We could update a measure found to have poor validity. We could contextualize the results by showing the old measure and the new measure. Again, we don't want to do that, but we can place it in context. There's data that's now available that should be used as a control. Some of these may be conscious, questionable research practices or QRPs. Hopefully they're not. I don't like to have a nefarious view of human nature because many of these could just be unconscious errors. We don't know that ExecuComp has an error, but it trickles into our study. Or practices evolved to where, a correlational study used to be the gold standard in 1970. And now we utilize very advanced regression techniques, and we have models all across time with various iterations. So practices evolve, and the prior justified path, we may now have new knowledge that says it's not. That's fine. Databases change, et cetera. So we can put those in context as well. That's one alternative use of multiverse. So some exemplars, if you want to dig into this before I walk through it again. Again, it offers choices in aggregate. One of the best examples that I can see is Schweinberg et al.'s OBHDP. Some of you OB scholars may particularly be in tune with this because there's many, many authors. And what they did was they crowdsourced the analysis. They sent all the authors the same data set with the same broad research questions. And they asked them to send back their analysis with some justified steps. So all of the measures and the analytical approach were unconstrained. They just sent them the raw data with some broad guidance. They then threw out responses that they could not reproduce or that they believed were unjustified, whether it was an error or maybe a questionable research practice. They dropped those. And what they got out of it is here's the z-scores across their analysis. You can see the scores in red are statistically significant p-values. The two there in black are statistically non-significant. But you can see just from the depiction of responses, they had a very strong negative effect with a z-value somewhere around 7. And then if you see the upper right-hand corner here, they had a very, very, very strong positive effect with a z-value of over 100. So many standard deviations out. And they had all responses in between. So they can offer evidence in aggregate across all of these analyses and say, what's our aggregate effect here? Okay. So the depiction in a typical a bell curve here or a typical plot, again, recall that the errors were dropped. We have the 105 z-score positive, but we can analyze how much conclusions change with any alternative choices. Say, how did we get to this 105? Which choices or which universes matter? Maybe there is a universe that's theoretically relevant where it is that strong, where we can see the average clusters a little bit positive, but much closer to a traditional z-score. We also then could, look at this negative universe and say, maybe this universe with a negative value that's even stronger than the 105 z-score, maybe this universe matters, and we could develop theory just about that universe. So it poses opportunities to build theory just by looking at these in aggregate. Here's many exemplars. They're often outside of the management domain, but I find a number of them informing when I'm trying to apply this, just getting completely out of our own comfort zone and saying, okay, how did they use it in fertility on religion and politics, or the power pose studies, disparities in police use of force, et cetera, et cetera. One that I particularly like, which we'll talk about in a little detail, is Sarma. Sarma et al. 2018 not only provides the code to execute this, but they discuss an example, which is the names of hurricanes and the damage of the hurricanes. So it's just kind of a fun one to think through, just from a non-management standpoint. Just, that's interesting. There's reason to believe this, but how robust are the analyses? So it's a fun one to walk through. So there's Sarma's exemplar. He provides the code in R. And those of you who don't use R, there's also various alternatives, Stata, Python. You could do this by hand in theory. Liu et al. Provide nice Stata code. So there are exemplars to follow if you're looking for code to actually execute this yourself. So what does this multiverse actually produce? So I developed a hypothetical multiverse here. Sorry, my mouse clicked ahead. You can see there's 7,500 universes in this hypothetical specification curve. And you can see here, the top depicts the coefficients from negative to positive. I just put the 0 in there. The red ones are p-values that are non-significant, and the green ones are p-values that are significant. So it gives us a nice specification curve. It gives us a quick depiction on the top portion of the graph of what the relationships look like. This question, like many others, has many valid alternative universes, things like sample frames, measures, specifications, analysis, etc. These are depicted in the bottom half of the multiverse output. And I'll walk through these a little bit. For example, you can see that we have this visual depiction. And then I will note later on, you can couple this with analyses once we identify some of these visual to actually help us determine which ones are the main drivers. But the visual depiction can also be helpful to walk us through this, which I'll try and do. So if we start with the 7,500 universes again, we can see that these first ones where the line is solid, there's no variation, those are justified and agreed upon. These are things where there isn't a reasonable alternative. There's only one best practice, so we wouldn't deviate from that. You can also see how some of the others have dashed lines, and this corresponds to, if we take it up to the top specification plot, this would then correspond to which models and which results. But you can see how there's others that are justified, but there's many alternatives, or there's options. And this depicts the entirety of all of the options in one graph. You can also see at the bottom, again, we should throw these out. We should not include these unjustified alternatives, but if you force them in there, it gives a pretty good indication of how these unjustified results would affect our robustness test as well, which we'll walk through. Okay. So if we go from there, you can see just very briefly, if we focus on this purple, this light purple color at the top here, this choice seems to be of consequence for our results, in that the solid purple line on the left, we start to get a much more negative coefficient below 0. Whereas if we omit it on the right-hand side there, we start to get a positive effect. And even at the far right, we get a statistically significant effect. So we can see how this choice alone seems to have a meaningful impact on the results. This middle section here, if we implement this light purple option, we have all statistically insignificant effects. So if that's our goal, or at least we know that our results are sensitive to this, and we can then also identify how they're also particularly of consequence in combination. So if we look at the purple line with this darker pink line, where it is the unjustified alternative, with this light blue that's a justified alternative, we can see how the results begin to approach statistical significance on the negative side, just by looking at this depiction. We can also see how if we include those same ones here in the middle, we get these, again, statistically insignificant effects, although positive. And if we continue on, we can see how we can use these coupled with analysis such as a robust regression to find which predictors are strongest among the choices, so we don't just have to rely on the visual prediction. We could actually determine that this purple choice is driving much of the variation, or the blue choice is driving variation. But we can use that to help place these unjustified things in context and also identify what the sources are, so we can then determine, is that a justified choice? Is there theory for that choice, or do we need to build theory to explain that particular universe where the results are what they are? So this is our hypothetical multiverse. Finally, circling back again, why is this needed? This is needed because if we think, well, what about just a number of robustness tests? Even if we remove, and I tried to X these out here with a red X across the unjustified alternatives there on the left, which we should remove those. So we've just removed 100 unjustified alternatives out of 7,500. So even considering that, and even considering which choices are of consequence, particularly in combination, and the justified alternatives, we could see how even a limited number of robustness tests, which the panel on the left is 500 robustness tests, and you can see that we could have a negative effect across 500 robustness tests with reasonably justified alternatives. And on the right-hand side of the depiction, we could have 500 robustness tests where we have a positive and statistically significant effect across many alternatives. So if this was a typical journal paper, depending on which way our theory was going, we might have identified an effect, done 500 robustness tests, which is more than we would typically ever expect in our papers and reach a conclusion when we extend it to the 7,500 universes, it doesn't appear to be more broadly justified. We maybe have a fraction, which in this case is about 2,500 universes, or a third of the universes where we have a statistically significant effect, and 2/3 of the universes where we have non-significant effect. We have about 1/5 of the universes where the relationship's negative, and the others where it's at least positive, although very close to zero. So you can see how, even with a limited number of robustness tests, which 500 is far more than a limited number, we may be masking the true effect. So we might want to move beyond this traditional way of thinking of robustness tests to include multiverse, or at least that's our premise. That's what I'm hoping to sell you on, is this can be a tool to help us. So in conclusion, even after removing the unjustified alternatives, which we should, and conducting additional analysis as is needed, do we have theory as to why the choices and combinations produce different results? If the answer is yes, then we've produced a stronger inference test or a better test of that theory. If the answer is no, then we have sound evidence as a basis for building theory, e.g. about the context where this relationship unfolds in a certain way, perhaps as a moderator, or the contingent nature of the relationship due to an identified alternative. So we hopefully have identified the sound basis for either testing our theory or building new theory. Okay, so hopefully I've walked you through multiverse, what it's going to accomplish, kind of as a ground floor introduction. And now I'm going to walk you through an example in the context of COP. So as our starting point, there's mixed findings with different theories that relate CO gender to COP. There's some economic logic of supply and demand, such as the resource-based view, which suggests the value and rarity of female COs, so they would earn a pay premium. There's theories of job-related schemas and stereotypes that suggest systematic biases towards female COs or against female COs, associates with a pay discount or a pay deficit. So we have two contrasting logics. There's findings that support both. We also have theorizing that suggests that societal mechanisms, things like the rule of law, norms around pay transparency, that actually suggest there's no difference in gender on pay. So we have three broad buckets of theory here, and we have very mixed findings. But importantly, these mixed findings, hearkening back to our example of the robustness tests, they're conducted in a limited number of universes. So even in our two robustness test examples, we had 500 different universes with different results, 500 positive, 500 negative. So multiverse can help us compare these findings across all of these universes as a way to help build our theory about why. So if we apply multiverse to this question, extant theory guides our multiverse construction. So what we did to guide our construction is we found 68 papers using execute-comp data. There are many more papers that use data, for example, from China, from other countries, but that's immediately going to be incommensurate. So we limited it just to studies that used execute-comp data. And you'll see why, because we're going to generate 13,000 universes. So if we added China, we would immediately double that, plus any nuance in China. If we added studies in the Scandinavian countries, this would just explode. We found over 1 billion combinations very easily. So we limited this just to those that we could identify in FT50 journals, and we narrowed it only to if two or more studies utilized the approach. So we might find a sample that's unique to one measure, or at least a sampling frame that's unique to one study. So just to narrow this even further, we used only those studies that are truly conflictive results, meaning there are two studies utilizing the justified alternative. So we have 13,824 universes. So I put on here these three books. These three books probably would not hold all the tables, right? If we were trying to do this in our traditional journal, yeah, this is probably one of the easiest desk rejects of all time, right? Too long, please cut. So 13,000 universes, there's no way we could present this in a reasonable way without the benefit of something like multiverse. So what we did there is now we have our reasonable alternatives. We had 13 choices here, and we mapped out the reasonable alternatives. We narrowed them down. If we multiply the combinations together, that's how we arrive at 13,824. And you'll see here, those of you who are familiar with this line of research or broadly with strategy research, you'll see that there's some similarities across all models. So firm performance measured as ROA was in almost all of these papers, right? So we would never exclude it because in this case, there are 13,000 universes just with this. So ROA, very common as a control. So there's only one option for that measure of firm performance. So we don't have alternatives. It's in every model. That's the only option. You'll see others, such as firm size. It's also always included, but sometimes it's measured as assets. Sometimes it's measured as employees. So now we have two options there. Hopefully you get the gist. There's some other justified differences, such as sampling frame. Newer studies obviously are going to tend to rely on newer data. Some of the older studies obviously are going to rely on older data. This makes sense. Outlier treatment. Sometimes people use pay Windsorized. There's reasons why. Others use the raw value. There's reasons why in terms of interpretation. Some of this could be the training that one receives, the journal norms, the associate editor's desire, but you can see how there's different alternatives. Whether we include or exclude women on compensation committee, say 5 years ago, that data just wasn't widely available. Since we've had a number of databases that now report this type of thing, so it's easier to include, but there's papers that either included or excluded. So you can see how there's different justified reasons why researchers, even absent questionable research practices, would have reasonable alternatives. And this is completely normal and really good for science that we have justified alternatives. There's not always just one best way, but Multiverse can help us pit them against each other. So even something as seemingly simple as CEO tenure, is this as a CEO ever? Is this as CEO in that firm? Or is it even needed? So something very simple seemingly can be much more complex. Hopefully you get the gist. This is our universe. Now let's get into the results. We'll get to the specification curve that we showed you again in a little bit. But newsflash, there's going to be great variability in the estimates. If we look here, I plotted just the z-values, the estimate itself, and the p-values. You'll see at the bottom, highlighted the estimates, the z-value and p-value. And you'll notice here on the left, on the vertical axis, there's two measures. This is the actual value of TDC1, which is the actual value of pay. The bottom one is the logged value of pay. Again, these are very common ways to do this. So you'll see two different sets of results, but they broadly tell the same story. On average, our results indicate that female CEOs earn, on average, a pay premium. So you can see here, I drew the vertical axis on both of these two graphs at 0. So most of the data is to the right of 0. There's a pay premium. If we average those out, the average is about $560,000 positive. Okay, but you're also looking at the other ones. Here's kind of the z-values, right? Here's the p-values, or the z-values. You'll see that, most of them are positive, but if you're looking at the values there, there's not many that are above a threshold at which we would have reasonable assurance that the relationship exists. So while it's on average positive, most are not statistically significant at our common threshold of p less than 0.05. That's not to say that p 0.05 is the perfect number. There's some that are p 0.051 that have the same practical implications. We could enforce more stringent p-values if we wanted to do that. I'm great with both of those arguments, but for the sake of simplicity, you're just looking at p 0.05, which is very common in the literature. You'll see that not many of these effects are statistically significant. So while it's on average positive, we don't have a lot of assurance here that this effect is statistically significant. This is not something that we would most likely feel comfortable taking to practice or putting action in. So what do we do from there? Again, taking this p-value, if we just took the thresholds I put in the middle there would be the thresholds where it's not statistically significant. So we see that the majority are not. So from there, we can hopefully identify the sources of the variation to identify how we can move knowledge of this forward. Maybe it's that society is advanced, or maybe it's that there's contexts or certain universes that we need to delve into to explain theory. So if we put our specification curve up here, and this is just one of the four to try and simplify, this is TDC1 here. We can find patterns visually, as we did in our early example in the specification plot. And we'll see here, we can also use a robust regression to identify the primary sources, which in our example here is that the sampling frame determines almost 60% of the variation, and the measure of firm size accounts for almost 20% of the variation. So we have about 80% of the variation explained by these two factors. There was a handful of others that were much smaller, so we're focusing just on these two, sampling frame and size measure. We can see those visually in our specification curve plot, but if we look at simple size, one may ask, well, is it just that it's going away over time? And it's not. It's not just a straight linear relationship with time to where, hey, we've solved pay inequality, so this is only present in earlier years and not later years. So it's not just that the effect goes away in later years. It's also not as simple as just one size measure or the other. We may think, well, you're using ROA in the analysis and you're using assets, so those models are probably subject to multicollinearity bias because both of them are fundamentally scaled by the same value, so there's some shared variance. We investigated that, and it's not just as simple as firm size measured as assets as inflating this in a variance inflation factor sense. So it's not just a real simple story here, which points to Multiverse helping us identify this and saying we need to dig deeper. We need to know what about these size measures, what about firms that are larger in assets versus firms that are larger in employees, what about certain years or combinations of firms can help us explain this. So that's where we can use Multiverse to turn to theory building. What about these can help us explain this? Put differently, these factors of time frames and our firm size measure point to the contingent nature of the existing logic. It's not that the economic logic is right or wrong, that the bias logic is right or wrong, or the societal-based theorizing is right or wrong. What it is that there's certain contexts in which we have support for these, certain contexts, the majority of them, in which we don't. So this is a contingent nature here to where we can delve down and have a better test of our theories, but also develop nuanced knowledge. So recall how. Our existing theory as step one guided our multiverse construction. So we've immediately developed stronger inference testing. We've identified these justifiable decision points, and we've investigated some low-hanging fruit reasons why, which was the time frame and the size measures, and we found that these aren't particularly robust, or so they're more sensitive. So evidence from that, now that we've done that, can help us guide this theory building. If variability, which we identified, we can then turn to that as a clear theoretical driver. And if we don't have a clear theory, which we don't believe we do at present for those two differences, then we can build it. So these results mechanism logic, it's that there's some nuance here and we need to delve into it. So from there, we now turn our attention to theory building here on the contingent nature of these timeframes and these size differences based on assets versus employees. So that's Multiverse in a nutshell, our discussion, which hopefully I didn't go too fast. I apologize if I did. Again, there's these inherent researcher degrees of freedom. They're natural. They're even actually beneficial. It's good if we can conduct a number of different studies and triangulate our answer. This goes back to Campbell's work on the multi-trait, multi-method matrix. Ideally, we would have these degrees of freedom. We would have the ability to conduct experiments and conduct archival data and triangulate our answer. Sometimes we can't get that. and we don't have alternatives such as an experiment, such as a meta-analysis to turn to, so multiverse can be useful. If our choices result in mixed findings, there's not always a viable path. Multiverse may be a way to help us reconcile these differences and give us a state of the field aggregation rather than 13,824 different tables. This pares it down relatively quickly, identifies the key variation in a systematic fashion. So we've just done parsing through all of that data relatively quickly to arrive at where we can use for theory building and theory testing. So what do our specific results mean? Certain time periods and firms, we identified where there was a roughly 20% pay premium for female CO. This supports the economic logic in those contexts. It opposes the bias-based theorizing, again, emphasis in those contexts. The fact that there's a general weakening of the pay premium also offers some support for the economic theorizing, in that because there's more female CEOs, they're less rare, the premium would be lower. So there's some general weakening that we saw that supports this economic theorizing. That said, the general lack of a pay inequality suggests that these societal mechanisms may also be working in some way. But again, it's not just as simple as a linear pattern. We investigated that. So we need to delve deeper into what's specific about these mechanisms. What changes can we identify where a mechanism maybe strengthened or weakened it in this context? So here we need theory to understand specifically why, and then to use in practice. So it's not that this can be atheoretical at the end. If we don't have theory, if you're not familiar with Christensen and Rayner's article, very powerful argument for why we need theory. If we don't have theory here, then we can't use this in practice. So ultimately, this points us to the need for better theory. Okay, theory building from our study, it's not as simple as the timeframes or size measures. Although pay is increasingly transparent, which is a good thing in our context of CEOs, this may be the societal factor, since we see inequality at other levels where pay is less easily tracked. So we can maybe delve into transparency, but at the same time, that hasn't ruled out that there's many stakeholders that are increasingly able to pay attention to pay in this context that are not able to identify it in other contexts. So we can't disentangle these two mechanisms in this particular study. So we've got to delve deeper. It points to the opportunity to build theory to help explain these unidentified mechanisms. There's some nuance in size and assets that we need to delve into, and we probably need to leverage contingency theory and future work to address specifically what is contingent here that's pointing to these. So ultimately, we've ended up getting back to theory. Some important caveats that hopefully this emphasizes is this should not be Dust Bowl empiricism. I cannot emphasize this enough. Multiverse is a tool to better test our theories, but then also to help us build these theories. This isn't just Dust Bowl empiricism. We need sound theory, or we can't use it in practice. We can end up with any host of errors if we don't understand why. So Multiverse can help us get there by efficiently identifying fruitful paths. This should not be a tool for questionable research practices in reverse. In fact, it's everything but the opposite. This can help us improve transparency in our testing, and therein the confidence in results. So someone may be thinking, hey, I can reverse engineer this, find the most robust results, find that 500 subsample of universes where this is robust, and just write to that 500 subsample, and I'm going to have a very good odds of that passing methodological muster. While that's true, I think, first of all, there's only a small percentage of our field who are nefarious actors. Most of us are in this field because we care about knowledge and we care about the discipline. So if anything, this helps us do the opposite, because there's a whole host of alternatives to that 500 robustness that we can identify and easily assess with Multiverse that should increase our confidence in those results, not decrease it, as unfortunately maybe some in the media are pointing towards our field. So hopefully this is a a way to help prevent QRP, because those that may be inclined to engage in this, we have a tool to help identify if that's the case. Third, multiverse should not be seen as definitive. A study that's done today with data that's most up to date today, if we use ExecuComp, that data as of today is a year or two old, because there's still, there's firms reporting data, there's a lag period for reporting. And in that year or two, many things have changed in our society. So these contexts continually change. Not only that, much like multiverse itself, multiverse has emerged as a tool that has advanced on other methods. There's going to be other methods in the future that advance upon this. So this should not be viewed as a definitive answer. This should be viewed as a step along the path towards better knowledge. So we should use this as a tool to help us replicate with theory, but also keep in mind that contexts are always going to change. And so those contexts that have changed since any multiverse has been done are potentially really fruitful opportunities for better knowledge. So this is not the end of the story. This is just a tool to help us get there and identify paths forward that can help us fill in that story with a little more insight. So the broad value, this can foster understanding. If we build justified universes, this can help us better test our theories, which will help us build knowledge. It can help us with better methods and practices. It can help us identify these unjustified universes and put them in context, which can render important insights in and of themselves. And my hope is that multiverse can inherently acknowledge these difficulties, because we can't talk about multiverse without saying, hey, there's inherent justified alternatives, and there's inherent difficulties in this line of research, because that line of logic sets up the need for a multiverse itself. So my hope is that multiverse inherently acknowledges the difficulties in the work we do and just facilitates it for us all. Q&A. So I will stop sharing screen and answer Q&A either in the chat or live in person. So again, thank you for your time. It's a big honor to be invited to present to an international audience. So thank you for having me, and hopefully you found something of value and interest in the presentation. So thank you.
Thank you, Aaron. It's so interesting, this study.
Well, I became really fascinated with it. This is not something that I have any exposure to until about 6 months ago, and
Wow.
I became very fascinated with it. And I thank my co-authors for really, helping work through this and just talking about ideas. Like, hey, how can we do this? How can we do this better? How can we use it? So yeah, I become fascinated with it.
Do we have any questions from our audience?
Yes, Shirley, I have a question.
Oh, yeah.
Amy here.
Hi, Amy.
Hi, Aaron. Thank you so much for this fascinating introduction of this multiverse. I mean, it sounds like, well, sooner or later, will this one become kind of a norm in our particularly strategy research, right? So I'm particularly interested about almost the final slide when you talk about this research, this approach compared with the reverse engineering issue.
Mm-hmm.
Because I mean, one part of it, this is also something similar like the harking, shocking kind of like comments, right? So one part of it, you already said that, okay, through this analysis, we can actually identify some areas for theory development, right? But so is it possible that, well, actually, so I have a theory, I did the multiverse, and then I notified, okay, well, notice that there's some areas that I can actually, based on that, build theory and explain it. And then can I then do a research, right? So show my final report. It's actually, okay, based on theory, okay, this is it. And then the multiverse support my idea.
Yeah, I think the norms of how multiverse is utilized in terms of our journals are still evolving, and this is a relatively new technique. So first developed in 2016, first probably implemented into a usable code package in 2018. At least to my knowledge, first into management in 2021. So I think the norms are still being developed in terms of, how would we present this? How would we use this as a tool? Hopefully, it can be used in a couple ways. One is if we have sound theory at the start, then this can be used as better inference testing tool, right? It can give us a sounder test of our theories because we're pitting the maximum number of alternatives against that theory, not just a limited number of universes. So I think there's power there. The second power is if we don't have theory, we're often like repeating the same cycle over and over again, right? We have, let's just take CEO pay inequality. We have, say, a handful of studies that just add an iteration that continues to support one line of logic or the other, right? And what multiverse can do is say, hey, both of those are right in those contexts, but what's driving the variation? And do we have theory about that? So it's not that the bias view is wrong. There are contexts in which the bias view is supported. It's not that the economic logic view is wrong. There's context in which it's supported. But if we look across all of them, we can see that neither one received particularly strong support. And we can turn to the why. And the why seems to be some indication of time frame. And we notice that it goes up and down, which means within those time frames, something changed, whether that's reporting requirements, whether that's the way pay is calculated or dispersed to executives, which then changes the way firms allocate it. So we really need to then delve down into that level of nuance to essentially rectify the multiverse. But I think the norms of that in our journals, I mean, that's going to take a lot of space, right? So we've narrowed down, but we're also expanding because it requires explanation. So I think some of that's yet to be determined, Amy. Hopefully this paper, hopefully the paper in OBHTP, there's now another one in OBHTP coming out. Hopefully norms will emerge around this so it can be a tool to help us.
Thank you.
You're welcome. Ultimately, hopefully you'll see something at JOM and you'll help establish these norms. You'll say, hey, that's a good tool. Let's get it out there.
Talk to Jerry about that. Thank you.
Okay, perfect.
So is it okay? There's one more question from the chat. A couple of questions.
So the first one is the data used in multiverse analysis all come from published paper. So in this particular case, this data came from ExecuComp and CompuStat. So our alternatives that we derived were only in published papers. So if you have access to the Wharton Research Data Services words, all of this can be recreated through that. So similar to meta-analysis, also based on literature. I'm not sure I follow the second part of your study. I think what you're asking is how we derived our multiverse. We tried to use theory, but we also tried to use the practices in our A journals, which should have theory for why ROA is included as a control, generally because there's differences across firm size that would potentially affect who is selected and the level of pay. So there is underlying theory that would guide the multiverse construction as well. Question 2, can multiverse analysis be applied to any type of research? As far as I know, Yulin, it can, and many of the examples that I listed as some exemplars, they come from many number of fields. They come from hurricanes, they come from criminology, there's one in plant pathology, there's a handful in management, one on narcissistic leaders. So it can really be applied to any research setting where we would have data that we could all agree is the base data, but then could be adjusted in different ways, such as how do we sample from that available data? How do we use that available data to derive a measure? Which control variables or which covariates do we specify our model with? What analytical approach do we use? So any number of reasonable alternatives there can be inferred in the multiverse. In terms of how we communicate the outcome in our papers, I think the Schweinsberg article, the 2021 paper in OBHDP, offers a good communication guide with respect to saying, hey, it's clear that different choices inform these, and that has some theoretical implications. So the next step is to delve into that theoretical nuance. So that's a guide, but I don't necessarily think, much like our current papers, I don't necessarily think there's one way to do this. So we'll probably see some general guidelines with variance around them, much like we see in our current papers in terms of general level of clarity, but definite variance in terms of stylistic approach. iPhone Z said, how is this different from meta-analysis? So meta-analysis is going to use already published coefficients, and that is going to be your input for the meta-analysis. The multiverse is going to use available data, and then it's going to derive reasonable alternatives, or you as the researcher, you, the collective you, global you, as a researcher, will derive the alternatives, and you will get the coefficients from each justified alternative. So if you think of this as a math problem, it's like a factorial where every choice is, the choice times the exclamation point, right? So it's 3 factorial, 4 factorial, 5 factorial, 6 factorial. So in a meta-analysis, say you have 200 studies, we could get to that 200 just by having 2 different measures, 3 different samples, 3 different analyses, and 5 different time periods. We're at 200 coefficients relatively quickly. Amy said, thank you for sharing. I wonder if the data in the sample papers come from different countries. How do we justify the context? Amy, this is one where I think there needs to be some norms. And this would be a really intractable problem, in that one way to do it would be to standardize all the estimates, so we have reasonable comparison. But if we look at the work of Travis Serto and John Busenbark and others, they point to some real problems with transforming base data to where even reasonably justified alternatives, like let's say we scale it all by country, we may end up with comparisons that, while they seem justified, are not. So I think if it were me, my intuitive off-the-cuff first answer would be I would try to do it a number of different ways, and I would treat the alternatives as one of the multiverse options and see if there's robustness across the many ways to try and compare. So I think we could try and do that, treating, again, the way that we would compare as a forking path in its own. We would standardize by country, we would divide by some common denominator, et cetera, to try and get a meaningful comparison, and treat that decision in and of itself as a robustness check, in effect, in deriving the multiverse, and see if the results hold or if the results are sensitive to measurement approach. We could also just do this within country first and see if we have really good justification that one country, isolating one country, we have a different effect than isolating another country. If so, that's pretty sound evidence that we need to look at country level differences as the main driver. Then when we combine them and analyze that difference, we should see very clear evidence to the effect. So I don't know that there's one standard way to do it. That's a really good question. This is one we wrestled with because we thought, hey, we could get access to some of this European data for sure and do the same thing. But hopefully step one was complex enough, and if this paper is successful going forward, then we'll move to step 2. But really good question.
Yeah, that's great discussions. I think everyone is so excited with this new method, and everyone is so interested in, finding out more of the things. So hopefully, I'm sure that the paper will be published somewhere, and then we can see it soon. So we can learn more to see the how we can do it in management. I already have several ideas in my mind. So
Yeah, wonderful.
yes,
That Sarma paper that I cited, Aberneal Sarma, or Sarma.
Yeah.
He publishes all his code, and he publishes the base data that he used. So he walks you through step by step. It's an example of hurricanes and deaths, but and he was really kind in helping us try and figure this out the first run too. So I point to that paper because it literally is a step-by-step guide of how to do this.
That's great. That's great. Okay, I think our time is up. Yeah, thank you again, Aaron, for sharing this very interesting study to us. And then we look forward to see your paper published, and then we are also looking forward to see more papers in this area that are coming out in the near future. Thank you, Aaron.
Thank you very much for